All right, to finish off what we did in class today, the last type of factoring we're going to look at is factoring by a difference of squares. So what that looks like is you're going to be seeing binomials. So that's two terms. You're going to have an x squared and a constant term, just like we have below, right? There's not going to be an x term. You're going to see that those two things are perfect squares. So notice we're seeing 4s and 9s and 25s, all of those things that we can take the square root of. And you're going to see subtraction in between them. That's the difference portion, right? Difference means subtraction. So to factor these difference of squares, we can do it a couple different ways. We can treat it like a regular polynomial, where we say they add to our b value. However, our b value is the coefficient on the x term. And since we don't have an x term, they're adding to a value of 0. And they're multiplying to, because the a value is 1, they're multiplying to our c term, so -9. Because they add to 0, that means they're going to be equal but opposite. There's 0 pairs. So what multiplies to 9? Well, 3 and 3. And if I make one negative and one positive, then it satisfies both of these expressions. So we jump down into our factors. X minus 3, x plus 3. And that's going to be our two factors. That's our factored form. However, we're going to notice a couple of things. We're going to notice that these 3's here, because we're multiplying to 9, because it's a perfect square, those are the values of the root of my constant term. And notice I have that x squared out front. And this kind of happens every time. But those x squareds, those x's out front, come from me saying, well, x times x is x squared, or the square root of x is going to be, the square root of x squared is x. So that's where those two values come from. And then because there's no x term, that means something has canceled out. So the fact that our b value is 0, the fact that we have no b term, is because we have opposite signs in our factors. So essentially what we can always do when we're factoring difference of squares is take the square root of the first term, the square root of the last term, and throw opposing signs in the middle. So let's try that with the next one. So this one would be a bit challenging because we're dealing with something that doesn't have an a value of 1. We'd have to use decomposition or some other method. So let's try our new fancy method. If I find out that the square root, let me erase this, let's get some room first. The square root of 4x squared, so I square root the 4, I get 2. Square root of x squared is x. And then if I square root, and I'm going to ignore the sign for now, I'm just going to square root the 25 portion, I get a 5. So what happens is that, again, the idea of our factors is that they're the multiplied version, right? So something like 2x times another 2x, when expanded, gets us that 4x squared. And something like 5 times another 5, when expanded, when multiplied, gets us that 25. And then if I make one of these positive and one of these negative, this expands out to 4x squared minus 25. Right, if I was to practice my expansion just to check, right, this is our final answer, but just to check, 2x times 2x is 4x squared. 2x times -5 is -10x. But positive 5 times positive 2x gives us a positive 10x. Notice those two terms cancel each other out. And then positive 5 times -5 is -25. So these middle terms, these x terms, because they're the same, but one was positive, one was negative, cancel out. That's why we have no b value here. That's why we don't see that middle term. So there's some practice. I want you to pause it. I'll put up the solutions in the document that I upload, so you can always check there. But give those last ones a try. Try out these 4 different factoring methods.